Hey class. For this video, we're going to build on what we talked about last time with limiting reagents and talk about percent yield. Now, we're going to use the same equation. Nitrogen plus hydrogen yields ammonia. It's already balanced, 1, 3, 2. First up, let's look at what the formula for percent yield is. It's simply a percentage, just like you've done in every math class you've ever been in. Maybe not every math class, but most math classes you've done percentages in. You're going to take your actual yield which is how much you actually came up with in a reaction, how much mass in the laboratory, divided by your theoretical yield. The theoretical yield is how much you should have came up with based on the math or based on the stoichiometry. And then, just like any other percentage, you're going to multiply that by 100, and that's going to give you your percent yield. Let's look at a basic question that might show up about theoretical yields and percent yields. Problem number 1 states, if your theoretical yield for this reaction was 476.5 grams of NH3, but you only produced 415.3 grams of NH3, what is your percent yield for that experiment? Well, we only produced 415.3. So that's going to be our actual yield divided by what we should have came up with. Now, no experiment is ever going to produce 100% of what the math tells us, because there's things that interfere with, like dishes not being clean, things that can contaminate the reaction. So you're not going to ever get that exact number, but the closer you are, the better. So the theoretical yield is 476.5 grams of NH3. And then, of course, we're going to times that by 100. So take your trusty calculator. 415.3 divided by 476.5. And I suggest doing this in 2 steps, because when you try to put too much in the calculator, bad things can happen. Times 100 gives us 87.15634. 15634. And generally with percentages, you're going to keep it at 1 decimal place, and that's how many we had in the question anyways. So we're going to round to that first one. So the final answer would be 87.2%. That's actually a really good experiment. If you got 87% of what you were supposed to, you did a pretty good experiment. Now, let's look at how stoichiometry can play a part in this. Problem number 2 is still a percent yield problem, but it doesn't give us everything we need. It says if we produced 125.7 grams of NH3 from 24.7 grams of H2, what is our theoretical yield? Well, to be able to calculate this correctly, we need actual and theoretical, whereas all we have is we produced 125.7, so that's our actual yield. We don't have the theoretical yield. Let's go ahead and put that in. 125.7 grams of NH3 over, we don't have the theoretical yield yet, but we do have how many grams of H2 that we used. As we talked about during the limiting reagent, problem, hydrogen is our limiting reagent for this particular equation. So we can find out exactly how much hydrogen will produce exactly how much NH3 or ammonia. So we have 24.7 grams. We want to get grams of NH3, and so what does that give us? A gram to gram conversion. Let's start with the basics. 24.7 grams of H2 and railroad track, railroad tie over 1. Got to turn grams of H2 into moles of H2. So how many grams are in 1 mole of H2? 1.008 times 2, which gives us 2.016 grams of H2. Cancel out your grams. We don't want moles of H2 though, we want moles of NH3. So now we got to find moles of NH3. What's our mole to mole ratio? Hydrogen to NH3, so it's 3 to 2. So for every 3 moles of hydrogen, we have 2 moles of NH3. Almost there. Now we can get grams of NH3. Cancel out those moles of H2. Railroad tie, railroad track. 1 mole of NH3 is how many grams of NH3? And as we talked about last time, that's pretty easy to find. We've got 1 nitrogen, 14.007, and 3 hydrogen, which is 3.024. Add those together, 11, 3, 17.031 grams per mole. Throw that into your railroad, 17.031. Cancel out your moles of NH3. You're left with what you want. Now multiply the top, multiply the bottom, and divide the two. So we'll take 24.7 times 2 times 17.031. All right. I hit a wrong button. $841.3314. Divided by what's on our bottom, which is 2.016 times 3, 6.048. So 841.3314 divided by 6.048 is 139.108. Again, we'll just round this to 1 decimal point, which means it's 139.1 grams of NH3. That is our theoretical yield. That's how much we should come up with based upon the math using our limiting reagent. So throw that in right here. 139.1 grams of NH3. And now we just do our simple percentage calculation. 125.7 divided by 139.1 times 100 gives us 90.3666427. All but one of those are irrelevant. We're going to round to 1 decimal point. That's 6. It's going to cause it to go up. Our percentage is going to be 90.4. And again, that's an awesome percentage. If that was a real experiment, kudos to whoever performed it. So as you can see, percent yield can be a simple problem, or you can have to do a few steps stoichiometrically to find your theoretical yield to perform that same type of percentage problem.